All right, guys, welcome back. This is our last page. Okay, this, as you can see, is page 11. Actually, we'll work on problems 1 through 8 here. So let's go over these together with you here. First two are just simplifying. Again, if we notice here, we're just having addition problems, so we're going to need to get a common denominator. So this one, again, it depends how you approach this, but I would recommend in this one here, since each thing's separate, to turn things into sine and cosine. So I would get sine over 1 over 1 over sine, turning cosecant into that, plus cosine over 1 over 1 over cosine. And we did these above. Hopefully you can see the shortcut to getting these problems. So if I do, for the first fraction here, if I do keep, change, flip, I'm going to get sine times sine. So I'm just going to simplify this to sine squared theta. Same thing here. Cosine over 1 divided by 1 over cosine just turns into cosine squared. Keep, flip, change. And what does sine squared plus cosine squared equal? Okay, not too bad. Not too bad. Okay, for the second one, again, if I notice here in my fraction, I do have a hold on a second. All right, sorry about that. Had a phone call I needed to take. All right, so back to number 2 here. So in our numerator with the cosine, cosecant squared minus 1. Again, if you remember, that comes from 1 plus cotangent squared equals cosecant squared. So if I want to solve this, I can just subtract by 1 on both sides, and I get, oh, okay, well, my numerator just turns into cotangent squared, all over cotangent. Well, what can I do? Well, I can cancel out 1 up here, 1 down here, to leave me with an answer of cotangent theta. All right. So those are just 2 quick simplifying ones. The last 6 we look at here will be all verifying. I'm sorry, I apologize. The last 2 are simplifying. I think I know that because there's no equal sign in there. That's right. So let's do some verifying here. So again, for this problem here, you have a couple choices. I see division on the left. I see addition on the right. Again, I'm probably going to work with division. And this goes back to a problem we did above where I'm adding in something in the numerator, but I have one term in the denominator. I apologize. You could turn 1 plus secant squared into tangent squared, absolutely. But I'm going to do this one. I like to separate. I have this, so I got 1 over secant squared plus secant squared over secant squared. If you remember, that needs to equal 1 plus cosine squared. Sorry. Well, that just cancels out, gives us 1. And what's the reciprocal? 1 over secant squared, 1 over cosine squared. And there you go. Now, some of you are going to say, well, wait a second, it's not the same. It's addition, guys. Remember, addition is commutative, so whatever order you do it in doesn't matter. Simple enough. All right. So for number 4, all right, I got my addition on the left, I got my division on the right. Now this time, everything's in sine and cosine, don't think anything's squared. This time, in my opinion, it's going to be easier to work on the left-hand side with the addition. I got a little bit more going on in the addition than I do with the division. So what I need to do if I'm adding on the left-hand side is get my common denominator. So I get cosine times sine. Again, what do I need in my first fraction? Well, I'm missing a sign in my denominator, so I multiply by sine in the numerator to get sine squared, bring your plus down. In this fraction, I am missing the cosine in the denominator, so I multiply cosine by top and bottom to get cosine squared. Oops, that's a little sloppy. Equals 1 over cosine sine. Now again, here we go again. Look, there's this identity. How many times do we see this? I get 1. So don't I get 1 over cosine theta sine theta equals 1 over cosine theta sine theta. Check. There you go. 2 steps for each of those problems. Not too bad. Okay, number 5. Definitely want to work on the left-hand side for this one. Got a lot going on. Just have a 1 on the left-hand side. So Let's take a look at here. Now, again, I have two terms, no fractions. I could use some Pythagorean identities, or if I notice, don't I have a secant squared in both? Couldn't I factor out a secant squared? Leave me with 1 minus sine squared. That's supposed to equal 1. Well, don't we know that 1 minus sine squared is cosine squared? And if you use the idea that I talked about up here, somewhere. Oh, there I did. Remember, when you multiply reciprocals, whether they're to the first, to the second, to the third, it doesn't matter. Whether you multiply those, you're going to get 1 because of reciprocals. So for here, same idea. You could write it again. You could do 1 over cosine squared times cosine squared, but I just know that right away that that's going to equal 1. Number 6, again, I definitely want to work on the left-hand side. Now this one's a little tricky. All right, this one's a little tricky if you look at the left-hand side. The key that sticks out to me is this numerator right here. This numerator has 3 terms in it. Okay, it has 3 terms in it. So that's like trying to factor something like, like x squared minus 2x plus 1. Right, plus right there, plus 1. Can't we factor that into just x minus 1 squared? Well, same idea is going to happen for this problem. It doesn't matter that I have sine squared minus 2 sine plus 1. It's still going to be sine of theta minus 1 times sine of theta minus 1. And look at our answer. Okay. Don't forget, we do have this in the denominator. So now that my numerator is all multiplication, guess what? I can cancel out one of the sine minus 1s and one of the sines minus 1 to leave us with sine theta minus 1 equals sine theta. Not too bad. Not too bad. All right, the last 2 problems again are just simplifying because again we have no equal sign, so we need to get a common denominator. So my common denominator will be 1 minus sine theta times 1 plus sine theta. Now again, to get a common denominator, what's missing in the first fraction in the denominator? The 1 plus sine. So multiply that in the numerator to get 1 plus sine theta. Plus this fraction, what's missing? The 1 minus sine. So I got to multiply the numerator by 1 minus sine of theta. All right, what do we notice happens here? Then our sines and our numerator cancel out. And we are left with 2 over 1 minus sine squared theta. Again, I'm doing that because, again, I can FOIL my denominator doing multiplying your binomials, which are conjugates of each other. So don't I know that this turns into 2 over cosecant squared? And we just got to get rid of that fraction as our answer. So we get 2 secant squared theta. Okay. All right, and then the last one. I'm subtracting a fraction, and I really should get a common denominator. I'll put it over 1. Won't our common denominator just be cotangent of theta? So my first fraction, again, I'm missing that cotangent denominator, so I'm going to multiply that cotangent in the numerator. We did this one before. Okay, minus the denominator doesn't change, so the numerator doesn't change. And again, what is cotangent squared minus secant squared? Well, again, you got to do a little manipulation. Remember, you have to, it's 1 plus cotangent. Yeah, it's exactly what we did up here, right here. No, not that one. I'm sorry. This one in green up here, but it was it was tangent instead of secant. So the same process is still following there. So to get this answer again, we know that our numerator is going to turn into negative 1 over cotangent of theta, which simplifies to negative tangent of theta. All right. And again, if you don't see that real quick, 1 plus cotangent squared equals cosecant squared. I have to subtract this from both sides. Give me the cotangent squared minus cosecant squared. But then I also have to subtract that 1 and move it over, so it ends up equaling negative 1. So that's how I get that in. Okay. All right, so this finishes up this worksheet. The last page is the answers to some of the questions that we did above, not all of them, but some of them, but I have all the answers for you. So hopefully this helps. Okay. Don't forget, you're going to be getting your quiz to work on Thursday. That quiz will be due on Sunday night. So if you have any questions, please don't hesitate to ask.